Good morning or good afternoon or good evening whenever you're watching this. Today we're going to talk about midpoint and distance. So midpoint is literally just what it sounds like. It's that middle point or the point in the middle, right? Midpoint. Distance is the length, how far apart two things are. So if you take a look at this number line that I have right here, I start at 5 and I go to 60. So when it says what is IT and there's no symbol on top, that is asking you to find the distance. It just wants to know how far apart is it from I to T. So if I start at 5 and you just count all the way over to 60, just think 60 minus 5, I traveled 55 units over. And you could count if you wanted to and do like 6, 7, 8, 9, 10, all the way up to 60. Just take you some time. So the question is, where is the midpoint of IT? The easiest way to find the midpoint is to just split it in half. Just think, where's the middle? So the easiest way to do that is if I take my start and my end, so 5 and 60, and I'm going to add them together. So 5 plus 60 means a total of 65. And now I'm going to split that in half. So 65 divided by 2 is 32.5. And that's my middle point, would be at 32.5. So if I am over here at 32.5, what that means is that this distance from 5 to 32.5 should be the same as 32.5 to 60. And the way you can check that is just like what we did up here, is ask yourself, like, if I go from 5 to 32.5, if you subtract, you'll get 27.5. And then if you go to the other side and you ask from 32.5 to 60, so I do 60 minus 32.5, I also get 27.5, which means that 32.5 is in the middle. I can even add ticks just to note that that is the midpoint and that those pieces are congruent. So now the question is, what if you're not on a number line? What if you're on a graph? So what if you have X and Y coordinates? So remember that our first number is always the X, and then our second number is the Y. And remember that for X, you go horizontally, and for Y, you go vertically. So -3 means I'm going to start at my origin. I'm going to go left 3, and then I'm going to go up 8, which is off the graph just by 1. That's okay. I can still put that point there. I'm going to label it B. So Y is at -3, -2. So now I'm going to go left 3, down 2, which would be right there, and I'm going to label that Y. And so then, what is the distance? What is BY? So what is the distance from B to Y? I can count. But also, if you just remember that this is at -3, 8, and that this is at -3, -2. So I have 2 here, and then I'm going to have 8 slots there. Don't count those loops. But if I go from -2 up to 8, that would make a total distance of 10. And because it's length, I'm going to say 10 units. I don't know if it's inches or feet or miles, but we're just going to say units for now. So then the question is, well, what is your midpoint of BY? So if I have this segment BY, I know that my middle is going to be somewhere on here, probably around like somewhere in this area. And if I know that I was going 10, just ask yourself, like, if I was 10 all of this way, then I should be going 5 and 5. So I should go 5 in. The other way I should be going 5, which would put my midpoint right here. And that point is left 3, up 3, so that makes my midpoint, I'm going to call it M for midpoint, at -3, 3. I have 2 numbers because now I'm on a number line. So let's take a look at another one. The endpoints of AB are A is at 1, 2, and B is at 7, 8. Find the coordinate of the midpoint, M, and then verify that M is the midpoint using the distance formula. As we're stepping things up a notch here, as you're going to see in our graph, we have formulas. We have geometry formulas. That way you don't have to do this long process of counting or going through all of that. There's a shortcut or a trick to this. So I'm going to go ahead and start by just graphing my points. So A is at 1, 2. So I would go right 1, up 2. And then B is over at 7, 8. So I would go right 7 up 8. There's B. If I go to connect these, it's not as straight, it's not as easy as it's going to be when it was on this graph up here, and I could just easily count and say it was 10, and I could find the middle. It's a lot harder to find out what's this distance, and then if I'm trying to go to the middle, I mean, it looks like it's about right there, but how do you know for sure? How can you prove or justify your answer? And that's where we have this amazing midpoint formula that comes into place. So here's how you find the midpoint, and this formula might look a little crazy, but it's just saying x1 plus x2 divided by 2, and then you're going to find y1 plus y2 divided by 2. All that's saying, that this x1, x2, that's just saying add your x's, divide it by 2. Add your y's, divide it by 2. So sometimes you'll see people, and they'll literally just write add x, divide by 2, add y, divide by 2. So that's all that you have to do to find your midpoint, and then we're just going to put it on our graph and kind of verify it. We have an idea of where it should go, right around here, but now we're going to figure out if we're actually right or wrong. So add my x's, and I could label my points x1, y1, x2, y2. So I'm going to add my x's, so 1 plus 7. So 1 plus 7 is 8. 8 divided by 2 is 4. Now I'm going to do the y's. So for y1 is 2, plus y2 is 8. So 2 plus 8 makes 10. 10 divided by 2 is 5. So that's not my answer. Remember, I'm finding the midpoint. I need to write it as a point. So I should write my answer as a point, 4, 5. And then I'm just going to go over to my graph, and I'm just going to double check. 4, 5 should be in the middle. So over 4, up 5. And there's point M. That's it. That's your shortcut for midpoint. Add x, divide by 2, add y, divide by 2. Now it says verify that M is the midpoint using the distance formula. So if M is the midpoint, what that means is that the distance from A to M should be the same as the distance from M to B. So I'm going to do distance twice, and remember, I do have a formula here. I need to find the distance from A to M, and then I also need to find the distance from M to B, and they should be the same. They should be congruent. They should be equal. Okay, so my distance formula, and this always looks really scary, but it's not as scary as it looks, is D equals, for distance equals, a really big square root sign, parentheses, x2 minus x1, parentheses squared, plus y2 minus y1, parentheses squared. It might look scary, but it's not. It's just saying that we're going to plug in numbers here, 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 and then we're just going to go through and kind of simplify it, allowing the calculator to do some work and going from there. So back to this. I know A is at 1, 2. And I know M is at 4, 5. My distance formula was D equals a really big square root, x2 minus x1, parentheses squared, plus y2 minus y1, parentheses squared. If you have not already, I highly, highly encourage you to write down the formulas. They'll pop back up, but here's the distance one right here. So from here, I just need to label my points, and it doesn't matter which one is which. I'm just going to label my first point as x1, y1. So I'm going to make that my x1, y1. And then I'm going to make my second point my x2, y2. And now I'm going to plug those values in here, leaving everything else the same. So distance formula is a really big square root. x2 is parentheses 4 minus my x1 is 1, parentheses squared, plus for y2 I have 5, minus y1 is 2, parentheses squared. And if you remember the rules of PEMDAS, you do parentheses first. So now I'm just going to go through and kind of simplify this. So going through, 4 minus 1 is parentheses first 3. 5 minus 2 is also 3. and then I do my exponents. So basically I have 3 squared plus 3 squared. So 3 squared is 3 times 3, so 3 squared, this becomes 9, plus this over here, 3 squared becomes 9. And 9 plus 9 is 18. So my answer for the distance from A to M, I can go ahead and write A to M just equals, it's not 18, it's the square root of 18. And I don't need to simplify that. That's called unsimplified radical form. You just, basically it's saying that this symbol right here is a radical, the square root, and I have a number underneath it. So it's just the square root of 18. I don't need to go to the calculator and find out what that is. I haven't even touched the calculator. I just know that A to M is the square root of 18. And now I need to find the distance from M to B and figure out if they're the same. If it's the midpoint, remember that this should be the same as this. So here I go with M to B. I know M is at 4, 5. And I know that B was at 7, 8. I'm going to just use the same exact formula again. I'm just relabeling. So 4, 5 would be x1, y1. 7, 8 would be x2, y2. And now I'm just going to start plugging things in. So D equals a really big square root. X2 parentheses would be 7 minus x1 is 4 parentheses squared plus y2 is 8, so parentheses 8 minus y1 is 5 parentheses squared. And now I'm going to go through and fill in what was in my parentheses. So 7 minus 4 is 3, so I have 3 squared plus 8 minus 5 is 3 squared. Remember, 3 squared is just 9, plus 3 squared is also 9. Just ask yourself, squared means 3 times itself. 3 times 3 is 9. So the distance from M to B, square root of 9 plus 9 would just be the square root of 18. So the distance from M to B was also the square root of 18. That's it. So I did verify that M was the midpoint by finding the distances between A to M and M to B. And so over here, I know that this is the square root of 18 and that this is also the square root of 18. So let's take a look at another one. If I don't have a graph, it's okay. It just means I'm going to follow my formula. So find the distance and the coordinates of the midpoint given V is at 2, 4 and W is at negative 6, 6. I'm going to start with midpoint just because I think it goes a little bit faster. Remember that your trick for the midpoint is add the x's, divide it by 2, and then add the y's and divide it by 2. So adding the x's. So if I add the x's, I have 2 plus negative 6. That would be negative 4. Negative 4 divided by 2 is going to be negative 2. Now I'm going to add my y's. So if I go through, I add my y's, so I get 4 plus 6 is 10. 10 divided by 2 is 5. So my midpoint M would be at negative 2, that was my x, 5 was my y. There's your midpoint. So now I need to find the distance. So remember, distance is that kind of crazy long formula. So D equals a really big square root, x2 minus x1 parentheses squared plus y2 minus y1 parentheses squared. So I'm going to label my points and then I'm just going to go through and start filling things in. So my first one's going to be x1, y1. My second one's going to be x2, y2. Then I'm going to start filling things in. So I get D equals, really big square root, x2 is negative 6, minus x1 is 2, parentheses squared, plus y2 is 6, minus 4, parentheses squared. So negative 6 minus negative 2, and you can go to a calculator if you need to, that'd be negative 8 squared plus 6 minus 4 is 2 squared, and then I have a really big square root over it. Negative 8 squared is asking yourself, what's negative 8 times negative 8? And a negative times a negative is a positive, so I should never have a negative number in my answer because it should always be positive. Just think, you can't have a negative length. You can't go backwards and erase those steps or erase that mileage time. So negative 8 times negative 8 would be 64. So I have 64 plus 2 squared is 4. Then just ask yourself, what's 64 plus 4?
Teachers and staff, please excuse the interruptions. We're going to be testing the fire alarm. It's not a real fire. Just please excuse the interruptions.
64 plus 4, that makes me have a square root of, the distance is the square root of 68. And we're going to pick back up in the next video so you don't have to hear the fire alarm.